Let's start with a warm-up. Find 3 cities on this map that appear to be collinear. And reminder, what does collinear mean? Collinear means 3 points that lie on the same plane, so you can draw one straight line between them. So what are those 3 cities that appear to be collinear? They are Chicago, Bloomington, and Springfield. Lesson 1.2, use segments and congruence. So congruent segments, congruent means something is the same size and length. So XY is congruent to PQ. We denote this by putting little slashes on the lines. That means that they're the same length. It doesn't tell you what their length is, but it does say that they're congruent. We'd also write that as XY is equal to PQ, or we could say that segment XY is congruent to segment PQ. In geometry, between means that not only is a point between 2 other points, but it's also collinear with. So for example here, Y is not between X and Z in geometry. And this example, this would be between because you can see that Y is collinear with X and Z, meaning it's on the same line. So I call this the broken pencil property. The broken pencil property in geometry is called the segment addition postulate. So if you were to take, let's go back, if you were to take a pencil and break it in half, then those 2 broken pieces would be equal to the full one piece. So the segment addition postulate says that the segment XY plus the segment YZ is equal to the total segment XZ. So XY plus YZ equals XZ. This is the segment addition postulate, or in my class, if you want to call it the broken pencil postulate, that's fine. So let's apply the segment addition postulate to this story problem. The cities shown on the map lie approximately in a straight line. Use the distances to find the distance from Lubbock, Texas to St. Louis, Missouri. So it says that Lubbock to Tulsa is 380 and Tulsa to St. Louis is 360. So what is the distance from Lubbock to St. Louis? Well, we simply just add the 2. So 380 plus 360 is 740. So the distance from Lubbock to St. Louis is about 740 miles. So let's try a guided practice. In diagram, WY is 30. So we could say that this is 30 right here. Can you use the segment addition postulate to find the distance between W and Z? So WZ. Well, remember, the distance between means that they have to be collinear with. So the distance between W and Z, there's not a line drawn through them. So no, because W is not between X and Z. Use the segment addition postulate to find the distance of XZ. So we know XY is 23 and YZ is 50. So we can plug those in. So that would give you a total of 73. XZ is 73. So this is basic addition. We can use the segment addition postulate to find a missing length as well. So we know that FG plus GH equals FH. So we can substitute this in. So the longer distance here is 36. FG is 21. We can plug it in, and it's a simple subtraction. We're going to subtract 21 for both sides, and we would get 15. So now let's try one on your own. So if Vx is 144, and VW is 37, what would Wx be? So use the segment addition to solve this equation. Try it on your own. So I write out the segment addition postulate, plug in what we know, and subtract 37 to both sides, and we get Wx equals 107. This may have seemed pretty simple so far, but when it's all variables, it makes it a little bit more difficult. Point S is between point R and point T. So here we have it. And we want to use the given information to write an equation in terms of x. So RS is 36. We're going to plug that in. And ST is 4x minus 8. And we know the total distance is 60. So we have our diagram all set up. We know the segment addition postulate is RS plus ST equals RT. So the two smaller pieces equal the big piece. We plug in the value for RS and ST. And then we add like terms. So 3x plus 4x is 7x, and negative 16 minus 8 is negative 24. We add 24 to both sides, and we get 84. Divide both sides by 7, we get x equals 12. We're not done here, so I always sing a little jingle, plug it in, so help you remember that we're not trying to find what x is, we're trying to find what the two other segments are. We know the total is 60, but we don't know what RS or ST is. So we need to plug those back in. So let's first plug it back in for RS. So we have RS equals 3x minus. So when we plug in 12, we get 3 times 12 is 36, minus 16 is 20. When we plug in 12 for x and ST, we do 4 times 12 gives you 48, minus 18 is 40. And we can see that 20 plus 40 is 60, and that helps us verify that we didn't make any mistakes.